So I'll go through this again real quick. So if we got this, we're talking about unusual solutions, solutions that well, you're going to get some bizarre answers. And I'll work through this one again, just because we're recording right now. So for solving for x, in fact, let me give a little introduction here. If you take some number x, it's an unknown number, let's say we pick a number. Adding 7 will make this bigger, but subtracting 2 from x makes things smaller. So if you start out with x, is it possible for this to stay true? To make this side bigger, this side smaller, but this inequality is still accurate? Because now you got something bigger, here's something smaller. Well, they're not going to be equal. Certainly something bigger is not smaller than something smaller. So this is going to be problematic. Now, if we try to solve for x anyway, we're going to get nonsense. So if you try to solve for x in this situation, you're going to get something totally crazy, that 9 is less than or equal to 0, and it simply isn't. So this is not true. So what we say is this has no solution. Or we use this symbol. Let me just make sure I'm using the correct version of this. What's called the empty set. So what are we doing with this thing called the empty set? Well, when we solve an inequality, we're finding all the numbers that are going to satisfy that inequality. And is there a number that you can increase it and then decrease it, but the increased version is smaller than the increased version is smaller than the decreased version? I mean, there isn't a number like that. If I choose x to be 3 and I add 7 to it, I get 10. And then if I choose x to be 3 and I subtract 2, I have 1. But 10 will never be smaller than 1. So it's sort of like saying if you make $10 an hour, they give you a raise and you say, great, now I've got $12 an hour. But then they decide, well, maybe we're going to do some cuts. So we're going to reduce your wage to $8 an hour. Well, $8 is smaller than 12. But according to this, that wouldn't be the case. It's not true. There's no value of x that you can pick that would make this true. So that means there are no solutions, or the set that would usually contain the solutions, it's empty. There's nothing in there. So that's the first example I want to go through, unusual solutions. Any questions about that? All right. So we're still dealing with unusual solutions. Now let's say we have this. Let's see. A little careful here. Now let's take a look at this. For any number x that you could choose, is it possible, if you add 1 to it, that's always going to be true. I'm sorry. If you add 1 to it, it's going to be a little bigger. That's always true. But if you add 2 to it, that's even more. This is like if you get $10 an hour, you can get a $1 raise, or $10 an hour, you get a $2 raise. Well, the $2 raise is always better than the $1 raise. So what does this have to do with an unusual solution for x? Well, when we've done these solutions, we've gotten, so far, one of 2 types of answers. We either get intervals, say x from negative 2 to infinity or something like this. We might have to union intervals together or intersect intervals to get the overlap. But we're getting intervals. In other words, only parts of the number line. What we just saw now is we could get an empty set where no number will work for the inequality we came up with. So this is going to be slightly different. If we try to solve this, well, we get 1 is less than or equal to 2. Well, this is always true. It's clearly an accurate statement. But let's go back to this. Can you think of a number where this doesn't work? Where adding 2 to the number is bigger than adding 1? Is there any number where that doesn't happen? Like if you choose 10, well, 12 will be bigger than 11. Choose negative 10. Negative 10 plus 2 is negative 8. Negative 10 plus 1 is negative 9. Negative 8 is bigger than negative 9. Choose 0. 0 plus 2 is 2. 0 plus 1 is 1. In other words, this is true for all values of x. Any number you can think of, that will always be true. So the solution here is all real numbers. And the way we express this what this means is the entire number line is the solution, not just an interval or pieces of it, but the whole number line. So any questions about that? All right. So let's see here. So let me do one that's more from the compound into inequalities. Let's see, we have this. Now, what we learned last time is when we're dealing with compound inequalities, we're usually going to solve for x in the first inequality, solve for x in the second inequality. Well, that's already done for us. There's nothing less to solve. So we want to come up with the intervals that we're going to union together. Now, for the OR, we can use options from A and, or, we gotta be careful, options from B, also with options from, see, I'm getting my letters mixed up, options from A, also with options from B. We can use them both. It's sort of like, again, if you're trying to get into Math 107, what you can do is you can either test into the course. Also, you could take Math 097 and pass the course. So you have both of those options available to you. So we sort of list out all the possible options to get into Math 107. This here, we want to think of all the numbers x that will meet this standard, or they could also meet this standard. They don't have to meet them at the same time. So we want really sort of two collections that x could be. A collection of numbers that will do this, but also a collection of numbers that will do that. Union them together. We'll take the two collections, sort of like boxes of numbers, and put them into another box altogether. And that's why we use the union. So let's take a look at this. One way we can tell what's going on. Graph our intervals. For this first interval, x must be less than 2. So smaller than 2 is always to the left of 2. Then we have an open circle. That means we don't include 2. Now, for x greater than or equal to -1, well, greater means to the right. And since we have this equal to, we have a closed dot. Oh, I forgot. This is not Math 097. We use brackets and parentheses in 107. Sorry about that. In Math 097, you would use open dot, closed dot. In Math 107, you use bracket and parentheses. Now, when we talked about intersections or the and, that means we're interested in only the overlap. But when we're talking or, we want all the options together. So we have this option together with this option. So we want to put these two together. But if we merge these together, what we're going to get is this. We have this option gives us all the numbers up to 2. But this number will give us all the numbers bigger than -1, including -1. And it'll also give us the number 2. So as a result, we get the entire number line. And the way we describe this using intervals, again, negative infinity to infinity. So that's what's going on here. Now, what about something that we don't have a solution? Now we're dealing with an and. Now, unlike the or, where we get to include all the solutions together, with and, we can only have overlap. Now, x is not free to be in 2 places at the same time. X has to be in the same place at the same time. In other words, the x here has to be the same number we have here. It has to satisfy both inequalities at the same time. So let's solve these and see what we get. And if we reduce this, we get x is greater than 3 halves. 3 halves, if you put that in a calculator, it's 1.5. Now let's solve this one. Subtract 2 from both sides. Divide by -3. Oh, shoot. Sorry, let me fix something. I made a little mistake here. I want this turned around already. I want this to be a greater than. I'll give you a second to change your notes. So we want this to be a greater than, and there's a reason why. Looking ahead on this, we divide by -3, what's going to happen? This will then flip around. We're going to get this. So what's happening here? Well, I want to make sure this was written like this because I'm trying to cause a certain bit of havoc. And the havoc's going to be this. We're talking and, so that means this needs to overlap with this. We only want values of x that satisfy both of these. So x is greater than 3 halves, x is less than or equal to -3. Well, let's look for the overlap. So x greater than 3 halves. So it's just greater than. So we don't want any 3 halves to begin with. And greater than means to the right. Now this is why I wanted to make sure this was switched around, because ultimately when we solve, we got x is less than or equal to -3. So we're going to include -3. We got the equal sign there. And then we had x was less than or equal to -3. Less than. That means to the left. So here's the million-dollar question. Where's the overlap? Well, there isn't any. So what this means, because there's no overlap, and this is an and so that means we're looking for where these intervals overlap. Well, we have no solution in this case. So even when we're working with compound inequalities, things don't always work out. Questions about that? So we're going to move on to section 4.3. And what 4.3 is, it deals with absolute values. Now, just a quick review of what our absolute values do. Essentially, they make everything positive. And what they really measure is the distance a number is from 0. So how far is 3 from 0? Well, take the absolute value of 3. Well, it's 3 units away from 0. There's 1, there's 2. So how many units is it from 3? I'm sorry, from 0? It's going to be 3. Now what about the distance of -3 from 0? 1 to the left, 2 to the left, 3 to the left. It's 3 units away. Now we put on the negative to say, well, to the left. No negative means to the right. But we're not interested in being on the left or being on the right. What we're interested in is just how far away you are. It's sort of like asking your friend, when are you going to be getting here? You're going to meet them for pizza someplace, say patio dining 6 feet away. Everyone's got a mask unless they're eating. Maybe it's in the sunlight. The sunlight tends to do a lot of damage to COVID. So you've done your social distancing practices. They're going to meet you for lunch and continue on with those practices. And well, it doesn't matter if they're 10 miles away to the west or 10 miles away to the east, assuming that the roads are roughly the same. East or west doesn't matter. They're just 10 miles away. Same thing with this. Whether you're to the left or to the right, 3 or -3 is going to be 3 units away. So that's the idea of absolute value. Another way of thinking about it, it takes numbers and either keeps them positive or makes them positive. So let's try to figure out a question. The absolute value of x is equal to 3. Well, x is an unidentified number, and we want to identify it. So we want to ask this question. Well, the absolute value of what number gives you 3? Well, we've seen this already. It could be 3, but it could also be -3. Either one is valid. So when we give our answer for this question, we're going to have 2 solutions, -3 and 3. So this is the tricky thing with absolute values. There's a positive version, which is true, but there's also a negative version, which is also true. I'm just going to leave it like this. When you're dealing with absolute values, there's a positive version and a negative version. So that's if we're looking for the absolute value of x. What about something more complicated? Well, we're going to have a positive and a negative version. Let me explain how that's going to work out. So what we do is we say this is u. So going with this new identity, equation sort of puts on its Halloween costume. It's going to pretend to be U. Well, based on what we saw before, positive U is a valid answer, and negative U is also a valid answer. Now U, though, is 2x minus 3. So here we go. 2x minus 3 equals 11. Also, negative 2x minus 3 equals 11. So we're going to get two equations. Now let's solve the equations. And then this one, we got to distribute this minus sign. I'm going to do something a little different. I'm going to hold back here. I'm actually going to multiply both sides by, say, -1. So minus and minus will become positive. 1 times 2x minus 3 will be 2x minus 3. I multiply this by -1, you'll get -11. Divide both sides by 2. Add 3. Divide by 2. X is -4. So we get two answers again. So what we do is we solve two equations. We solve the equation as if there's no absolute values at all, or the positive version, and then we solve a negative version where we put a negative sign out in front of the equation, or this part of it. Now, I did something sort of unusual. I could have distributed this minus sign to those terms, and I didn't. I multiplied both sides by -1. So this looks like the positive version, and it's this that's positive and this that's negative. And that's how they do it in the book. And so I'm going to stick to the book's format. So in general, use an expression. That means it's a like 2x minus 3 or 7y plus 2. It's some expression like that. So when we have the absolute value of an expression equal to some constant number, It breaks down into the positive version and into the negative version, but then we multiply both sides by -1. We'll get u is -c. So when we do absolute value problems, we can solve these two equations to get our answers. So let me do an example. Let's see. So the absolute value of 2x minus 1 equals 7. So we're going to get two versions. The positive version and then the negative version. Now usually we'd have the minus sign on the expression, but again, we're going to multiply both sides by -1, and that will give us this. And you don't have to keep telling yourself that you multiply both sides by -1. Call this your positive version. Call this your negative version. Positive, negative, that's good enough. And then we solve for x. So for this equation, divide both sides by 2. For this other equation, divide both sides by 2. And that gives us our two answers. And that's it. So let me do another example. I'm going to throw a little curveball at you. So what about something like this? In this situation, what the recommended approach is, you want to solve for the absolute value first. So that means any outside numbers, we want to get rid of those. We want to cancel those first. And then once the absolute value is by itself on one side, then we'll work with the absolute value. So divide both sides by 2. Now we break it up into positive and negative versions. And then subtract 6 from both sides. Subtract 6 from both sides. And those are our two answers. So any questions about that? All right. So let's see here. So the next thing to look at are what we're going to call double absolute values. So let's say we have something like this. Well, this is always true. So this could be positive, and this could be negative, but they're all going to become positive numbers. So that's all right. Or they could just be positive to begin with. And that's going to be true because, well, this is 3 and this is 3. And they both could be negative. And that's true because they'll both come out to positive 3. So what's going to happen here? Well, let's take a look at expressions. And think of this. Do this a little differently. Oh, I will do one. Okay. So let's consider expressions u and v. Now, this is something in terms of x. It could be 2x plus 1. This could be 3 minus 7x, for all that we know. So what's happening here? Let's consider this. Well, what's going to happen is we basically have two situations that come out of this, but it's kind of hard to see that it's two. But if you consider all the possibilities, we could have u with v. We could treat v like it's that constant. Or we could do this. We could have negative u equals v. We could do something like this. Shift the negative to the other side. But if we think about these two options, they're really the same thing. all we're doing is moving the negative from this side to this side to get this. They represent the same idea. So we'll just call this u equals negative b. Now there's some other ways of expressing this. We could have u equals v. We could also do negative u is negative v. But here's the thing. These two represent the same idea. Multiply both sides by a negative, you get that. So, being that the case, if they really represent the same kind of equation, we'll represent them like this. So when we're working with double absolute values, what's going to happen is we're going to have a positive version and a negative version, just like before. Nothing's going to change. So it looks like it's going to be far more complicated. It actually isn't. I can go into this a little more later. I'm skipping some things here, but let me do some examples with this first. I'll pick one from the homework so you have an example in the text to work with. Let's go. So let's say we have something like this. We're going to break it down into a positive and negative version. Positive version, and negative version. So we're going to solve these. So add 2 to both sides here. Over here, I am going to distribute the negative sign. Now on this side, I could subtract 5x from both sides. On this side here, add 2 to both sides. This side divide by -2. X is -3. This side, we got to add 5x to both sides. This side's a little bit kind of behind in terms of where we're at with the other one. divide by 8. X is negative 2/8, and that reduces negative 1/4. And so these will be our two answers. So questions about that? So I want to go into a little bit more of why that came up. You saw the 3's and the negative 3's, and that's just kind of to show you the versatility of the absolute value. It lets you say negative 3 equals 3. It really doesn't, but the absolute value of negative 3 equals the absolute value of 3. So I just kind of want to go into why this happened. Well, let's say you have this. The absolute value of x equals the absolute value of y. Well, what can this say about x and y? In fact, I'm getting a sort of brainwave here. Hold on. No, that's okay. We'll stick with this. We'll go with this. So what does this say about x and y? Well, first off, x and y could both be greater than 0. Let's consider that possibility. They're bigger than 0. Well, if they're both positive numbers and the absolute values are equal, well then this means x equals y. Two positive numbers, if you take their absolute values, they have to be equal. Values to be equal. Now let's consider another possibility. Let's say they're less than 0. I'm using x and y because I want to give myself the freedom to say that they're two different numbers. But they don't have to be. So x and y are less than 0. So for the absolute value of x to equal the absolute value of y, again, you just need x and y to equal each other. Or if we want to make things positive, we could say negative x is equal to negative y, just to make things positive for whatever reason. We could have this though. And this is why I use x and y instead of x, instead of negative x. X could be greater than 0, and y could be less than 0. So what does this mean? Well, the absolute values, if they're equal, well, that means that x is a positive number. It has to be equal in magnitude to y, but We need to make y positive like that. Finally, x is less than 0, y is greater than 0. Well, what this is going to mean is we want to make x positive, so we put a minus on it, and so this positive would equal the positive y. So that's where we're getting these 4 options. And the 4 options, they all reduce down to this. But these are really the same types of equations. They only differ by a constant, -1. So solving for anything here, you'll get the same solution as you solve this equation there. So we'll consider these in the same and emphasize that one. Same thing here. You're just moving a negative to the other side. So if you solve this equation, the answer you get here will be the same answer you get here. So we're just going to emphasize this equation, and that's the results. So that's why we reduce it down to these 2 equations instead of trying to do all 4. Anyway, moving on. Any questions about that? You could think of it with the 3's also. So if you have absolute value with 3 equals absolute value with 3, that's because 3 equals 3. You could say that. In this case, if they're negative, again, you get -3 equals -3. If you've got one negative and one positive, if you try to remove the absolute values, it's only going to work if you make this one positive. Likewise, if you have a situation like this, if you try to remove the absolute values, you can still keep equality, but you've got to make this one on the right positive. And so that's the idea. So that's where these ideas are coming from. Anyway, moving on. So if you try to remove the absolute values here, there's no danger. Here, there's no danger. But with this kind of situation, you gotta include an extra negative. This situation, you bring in that one extra negative. So just to kind of go over again where some of these ideas are coming from. And so basically, when you're solving these equations, set everything equal to each other in a positive version and then in a negative version. Then you can remove the absolute values. So the last thing to look at today are inequalities with absolute values. So let's consider this. The absolute value of x is less than 3. So what this is saying is we want all the numbers x that if you take away their absolute values, or if you make, I'm sorry, not their absolute values, if you take all the numbers x, you make them positive, they'll be smaller than 3. So all the numbers, when made positive, are smaller than 3. So let's take a look at this on the number line. Sort of giving it away. But let's think of all the numbers smaller than 3 that are positive. Well, it's these right here. And also the number 0. So those numbers will work. But also these numbers here, like negative 2.9, negative 5, negative 2.5, negative 1, negative 0.5, these numbers also work. So like the absolute value of 2.5, less than 3. But same thing on this side. Negative 2.5 will give you 2.5, which is less than 3. So what we find to solve for x, in other words, get rid of the absolute value, we're going to get this. All the numbers x between negative 3 and 3, or as an interval, we're going to get that. Questions about that? So what's true with just plain x will also be true with an expression. So you have an expression u. If the absolute value of u is less than c, then u, if we try to remove the absolute values, it'll place the expression u between negative c and positive c. Questions about that? So let me do an example. So we want to try to solve for x. And solving for x, and I probably should have mentioned this at the beginning, we want to clean off all the numbers of x, off of x. We also want to get rid of these absolute values. So that's where we're learning techniques for getting rid of them. So again, we want to solve for this first. I want to solve for this first. So subtract 2 from both sides. Divide both sides by 3. And now what we're going to do This is our expression u on the inside. And this is going to be C. Likewise, we're going to get this. And so we solve for x. Again, we have to divide everywhere by 2. Or an integral form. And that's going to be your answer. Questions about that? There's one last type of problem to cover, and that's it. And then let's see here. So let's consider this. The absolute value of x bigger than 3. Well, again, what does this actually say? Well, it's all the numbers that if we pick them, if we make them positive, they'll be bigger than 3. So all the numbers, if made positive, will be larger than 3. That's what x stands for. So what are these numbers? Well, first off, numbers bigger than 3. All these out here. All right. But if we take a look at negative numbers, say negative 10. Well, if we made this positive, then it would be bigger than 3. 10 would be bigger than 3. So the numbers over here will also work. So in this case, our answer will be this. So in general, for an expression, this is what we're going to get. For an expression u, we're going to have 2 inequalities to solve. U greater than c also going to get you less than negative c. This is what we're going to get. So we could have x greater than 3 or x less than negative 3. And those are the two answers we had before. So x greater than 3, x less than negative 3. So let me do an example. Three x minus 8 greater than or equal to 7. Well, we'll have two versions. A positive version. And then, sort of like before, a negative version. So this time, we have an inequality that we flip around. So solve for x. Divide by 3. Now these we're going to union together. When you have an absolute value greater than, the answer is going to be a union. So this interval, x is always bigger than 5. So all the numbers bigger than 5 or equal to. So I better put a bracket here. Over here, we have all the numbers smaller than 1/3 or equal to 1/3. So bracket, and then we're just going to go smaller and smaller and smaller forever. So those are the two intervals. Now, the thing you want to be careful of is when we union these, we take the interval with the bigger numbers and we put it on the right. The interval with the smaller numbers we put on the left. And that's going to be our answer. Now, I just want to mention two quick points, real quick points, and then that's it. We'll be done. That'll be 4.3. But one more section, and that's it. I'll save that for Tuesday. But real quick, 2 points, and then we're done for today. First off, notice this right here. When c is less than 0, you have an absolute value greater than. Absolute values are always positive. Absolute values are always positive. It doesn't matter what we choose x to be. It could be negative 1,000,000. Negative 1,000,000 plus 3 will be negative 999,997. And that negative 999,997 will be made positive. This is always true. So when you have an absolute value greater than a negative number, the solution, all real numbers. Or you'll get something like that. So when you have something positive bigger than something negative, that's always going to be true. Positives are always bigger than negatives. And absolute values will make sure x is going to, whatever x does on the inside, it'll come out positive. Last example, and that's it. Thank you for hanging in there late. What if we have this? Again, C is negative, it's less than 0. This is not possible. The reason is absolute values are always positive. Positives can never be smaller than negatives. This can never happen. You can make x a massive positive. You can make it some, say, again, very incredibly gargantuan, so to speak, in magnitude, negative number, like -1,000,000. But this will turn it into all positive once we've done the arithmetic. Positive can never be smaller than negative. So the answer here is there isn't one. No solution. And that's it. So if you have any questions, let me know. Also, let me know about the recordings. That the board is, the board's staying, sort of in the middle there, and it's not a sort of being cut off by anything. If it is, let me know. I can put on a little camcorder or a little camera that can go with the webcam. So we'll be using the webcam and this other camera at the same time. And the other camera video I could upload to the internet. But that's it. Unless you have any questions, have a wonderful weekend. Oh, one other thing, just with the quizzes, some of the quiz scores got omitted. It's a setting that was defaulted into Pearson. I'm going back and I'm going to fix that. So you'll see the quiz scores start to factor in. If you have any questions, let me know. Office hours will start in about 7 minutes. And if you don't have any questions, have a great weekend.
Thank you.
No problem.
Thank you. Have a great weekend.
You too.